Good morning or good afternoon, wherever you are in the world, and welcome to this new session of Oracle Analytics Summit in 2020. Today's session is on Oracle Analytics Cloud, from raw data to automated insights. My name is Jorge Anicama, and I am a professional in data management and advanced analytics solutions with around 18 years of experience helping organizations to define and execute enterprise-wide business intelligence solutions. I think I have been lucky enough to work with different clients around the globe, from customers from Latin America, Europe, and North America. I work for DataVale. DataVale is a company with consultants specialized in data integration, enterprise applications, and advanced analytics solutions. And just wanted to mention one highlight: if you guys visit at the end of the session this website, you can be the lucky winners of these beautiful canceling noise headsets. The agenda for today tries to cover three important points. The first one is the road to automatic discovery, where I briefly talk about the evolution of software and hardware that led us to the current automatic discovery. The second is the business case that we had with a client last year. And the third is some of those details on how we did it. Well, the evolution of software and hardware has been such that it allows us now, or enable us today, to do very complex and computations, very intense resource computations, and therefore it needs some sort of explanation of how we came here. So you see on the upper half of the slide, you see how the software evolved. Initially, you had ideas like neural networks that actually began at the beginning of the 60s. Mathematicians back then, they developed these approaches and algorithms, but it was not possible to put them into practice because there was no possibility to do that amount of computations that was needed. And you see the evolution during the 1990s. These algorithms evolved and new contributions were added. Things like support vector machines, random forest algorithms were added, and maybe during that decade appeared companies like VMware that made possibilities to virtualize what was possible only on hardware, now into software. At the beginning of the 2000s, we had libraries that were devoted to machine learning. In this way, it created a community that could focus on adding more libraries or algorithms around the automated discovery. I would say this in this part at the end of the 2016, we have big achievements like machines like Watson, or we had the Facebook deep face algorithm. That led us to such capabilities with the software to do things that were unimaginable before. On the computing side, you have architectures initially were developed by von Neumann that evolved from the creation of the small transistors into very large scale circuits into chip that were possible now to create different types of computers running processes in parallel. Even concepts like quantum computing are right now possible because of this development of microprocessors being in such a small places like chips. To finalize, the concept of machine learning is also interchangeably used with artificial intelligence. By definition, artificial intelligence, you need to happen to 5 things. Usually it's around learning, reasoning, problem solving, perception, and the use of language. You have all these 5 concepts combined, and then you have artificial intelligence. Machine learning is a subset of it, and it's all about the pattern discovery. You have a lot of data, you try to find patterns, and once you have a pattern, you call it data model. And once you have a data model, you can use it to predict when a new data point appears. About the business problem, well, last year we have a customer from the finance sector approached to us and asked us to help them to resolve the following problem. They were using Oracle Cloud, but they also have a data retention policy that they have to keep at least for 2 years information about the users connecting to all the servers. Given that they were using Oracle Cloud resources, that information is stored by Oracle, but it is only kept for 90 days. So the problem was, how can we extend that period for longer? And one way that we envisioned was to find out if there was a way to extract the data from IDCS periodically and let the client store that information. In the end, we came up with an approach that is founded in REST API. So REST API libraries allowed us to extract the data periodically and handle those. And once the data was extracted, we can store it locally. The client decided to store it in an autonomous database for that matters. With that, obviously, the benefit the client had is to automate the extraction of that information seamlessly using a data integration technique, and therefore complying with the security policy, and also started to create historical information, and having this information on an Oracle Autonomous Database open up possibilities for additional analysis. Not only the traditional analysis of static or dynamic reporting, but given that we have now autonomous databases and also the Oracle Cloud Analytics, allow two different communities, the data scientists and the data citizens, that will allow to analyze data from the UI or from a more specific tool like the machine learning notebooks. And I'm going to share with you now a little bit of details on how we did it. A machine learning solution is as good as the data pipeline that will allow that machine learning to extract information from places that are difficult to access. And also to be able to capture large amounts of data sets to train your algorithms. Therefore, sometimes it's overlooked, this important point on how you can use data integration into your machine learning pipeline. The way we did it is by using the REST API approach. And for that, I'm going to proceed with the demo. In the demo, you're going to see that we are going to interact with IDCS. We're going to go and configure our application. We're going to get a specific information from that configuration. That configuration, in the end, will give us a client ID and secret ID, which we are going to use to immediately use it into our application for future sequence of calls to extract the data from IDCS. So all this is about Oracle configuration. Those first steps is going to be done in IDCS. And the ID and secret is just about the subsequent calls that we will call from our application. So we start by going to IDCS. Once we're logging into IDCS, we come to the sections of applications. In applications, you will define and register your application. This is a very important step. You come to confidential application, that's your option. The only required field here is name, so we'll go by that, and we put, let's say, demo Oracle Analytics Summit. We continue. On this piece, it's important because you need to define that you want to configure the client right now. So you select there, you select client credentials, and then you scroll down here because that's the piece that where you grant access to IDCS APIs. So you come to add, and then you come down here and select Identity Domain Administrator, click Add. And in the next step, those are the only two pieces are required. You select now additional permissions to resources, and you can configure that if you like. I mean, I will recommend to do that. Read the documentation for further details. For now, I will just skip it. And I will continue an authorization, then I finish. And at this point, you're gonna get the result of the client ID and the client secret. Client ID and client secret, as we already explained, are important values that you need to keep hidden away from any unauthorized resources, because this is gonna give access to any application to your resources. So this goes and close. And now you're gonna activate those at client ID and client secret. click OK. Now that you have configured your client ID and client secret, the next step is to be authorized. And to be authorized, you need to go and perform a test with a client ID and client secret. Once you have your client ID and your client secret, you can use it to subsequent calls to obtain the token, the access token. With the access token, you're going to be able to request for resources information. So this access token, we can test it. So we use Postman as a client tool to test your REST API. And we already have the client ID and the client secret. I have configured Postman so that you can use it in a variable, and that's how it is done. So I have that, and I will submit a request. This is the host. Also is my IDCS. I need to send this, and as a result, the response is 200. Okay, means that successfully, and it returns an access token. It's a very long string. And that is the token that I plan to use for the subsequent calls. On the request of the resource, you go to authorization, you go to the access token, we can define a variable, or else we can paste it here. And once it's there, I need to remove this piece though. Go here. Okay, it's done. I now can apply a send. The send is the submitted request, and the request is to find out all the audit events that are registered in Oracle IDCS. So as you can see, there are result of 8,846 results returned, and that's in a JSON format. All the previous steps now need to be consolidated into one process that automates the extraction so that you can put the data extracted into a single location. In this case, we decided to use Python as a means to extract the data from IDCS, and also that sends the data back to the Oracle database. So I'll do that, and you'll see in a moment. And that generates an output. And the outputs, as you see, are here for a few records, but you apply the concept and it will return all the information that you want. I just selected a few parameters that will bring back the information that I needed. Once the data is posted in an Oracle database, we can access the data directly from Oracle Analytics Cloud, opening possibilities for different types of analysis. One of those is the traditional reporting, and I'll show you an example of what that is. I have previously developed this report based on the information that we just submitted using the REST API and posted into a database. And as you can see, these are all the parameters that we were able to extract. And this is just a few of the parameters. There are many more that you can access from the log files and from IDCS. And as a result, I am able to analyze this data. And for example, this report shows you the number of attempts, successful attempts of logging in, the logins by these different users. This is this is historical information for the data set extracted. We don't have a timeline here, but that's not a problem. I can add that by, and I have dropped down here in the x-axis the timestamp, and that's why you see now a timeline, and you can see histograms for the number of successful attempts on this day. Successful attempts on this day, on the 25th, on the 26th, and this was in last year in July. I have another set of analysis, for example, by platform or browser. These are the counts of the many users, that use Internet Explorer that, perhaps, for example, successfully logged in or attempted and then the session expired, or simply they were unable to log in, right? 5 attempts using the Internet Explorer. And this is the case for Chrome, and this is the case for Firefox. I have one other that I also developed based on the log audit information, is the number of successful attempts of logins per day, but also per day, what's the activity. And we can notice here that there is a pattern immediately. It's obviously a pattern that two peaks that occur around at the same time. So we are not doing nothing extraordinary. We're just analyzing the information we extracted, but it's very important information. So based on this, we can define a pattern. And with this pattern, obviously, using machine learning techniques, we can apply to predict. We can always expect a high login, successful login around this time every day. So to finalize, I want to show you how storing this information extracted from IDCS can open up possibilities of new types of analysis. Analysis like, for example, clustering. And I'll show you very quickly how you can do that. Using that information and using machine learning technique that I can explain in a moment, we can create clusters. This is one example of a cluster using a machine learning technique that by means of using k-means. It's a very simple algorithm, but it gives you an idea of the patterns that appear in the data. So there are different clusters, the majority of this one, and we have a behavior there. And yes, it's not yet so deep, and there are many other techniques that can be applied, but I'm trying to make the point that you can have now at your fingertips using a tool like this, the endless possibilities of analysis of machine learning. And how did you do that? I'll show you very quickly. So what you have to do is you need to go to home, and then you can create a data flow. First of all, you need to create a data flow. In the data flow, you have to say what's your data source, and I say audit log. That's the audit log information coming from the table that we stored and extracted in JSON format or CSV. Now it's there. I can use all the attributes and select the ones that I do not need, but I want to use all of them. Maybe I remove ID, and what I want is common patterns. So I want to use the cluster. I need to train the cluster, meaning I want to know how many groups are naturally formed, and I will use the k-means algorithm. And I want to predetermine the number of clusters. Everybody knows k-means. You need to enter certain parameters, a minimum number of parameters, and one of them is the number of clusters. I'm going to say just 4 for the time being. And I'll go by the rest of the parameters. There are different parameters that you need to know how to set them. I'm going to save. Then I'm going to save this. This is the k-means data model for audit log. And then we save. And I want to save this data flow. I'm going to say audit log. What is this? Cluster data model. I click OK. And now I run. When I say run, what happening behind the scenes is you have the machine learning algorithm for clustering using k-means to find 4 different clusters. Now, once it creates those clusters, you can use that to classify new data. A new data point comes in, and you can classify which cluster that new data point belongs to. So that's really important, because if you consider that cluster that you're creating right now really relevant for your analysis, then you want to know and predict what class the new data point will belong to. So now that I have my data model, then I can apply this. Let's imagine I have a new data set. If I have a new data set that I need to know how they are going to be classified, I'll go to create again, because I need to create a data flow for that. And let's assume that we have another data set for which I don't have a label to which class it belongs to. I take this one, I click on add, and that now I can leave everything, because what I'm going to do is apply the label of which class this every row belongs to. And since I'm going to apply, this is apply model. So I'll come here, apply a model, and I have this model. The model was this. So I click on save. And when I save, these are the additional labels or attributes that are going to be added to my data set. What I need to do now is to save. So, and that's save data set. I can put that here, or I can do this data save. It's here. Save data. I can save the data. I need to do a name. Data set cluster new. This is the output. I save that. I need to save this because this is a new data flow. This is cluster labeling data set output. I do that, and now I run data flow. At this point, every record on my new data set, which didn't have a tag of which class it could belong to, is being labeled by adding these additional, the additional attributes that we saw in the past or moments ago. Now I have that data set, right? And this is called cluster labeling data set output. So if I want to analyze that data, I need to create a project. And if I go to project, I go here and I can create project, and I need to add a data set, and the data set is going to be the one that I just created. The data set cluster new, that's the data set. And that data set now will have these additional labels that were not done before, but as a result of the cluster algorithm. And in that way, you create your cluster, and you can say cluster name, cluster description, cluster size, and these other parameters, and you can start playing with that. So that's the way that we came up with the result of this clustering exercise, where you can define and find 4 different clusters and use that as a preliminary analysis on a further machine learning techniques analysis. That concludes the demo and the presentation. I hope this has been very interesting, and all the information provided is going to be useful to you. We appreciate the time and your attention to this. And now we are open to the questions and answer section.